Hello everyone. Today we will be continuing our discussion of apportionment with probably the simplest apportionment method, and that is Hamilton's method. Now, Hamilton's method essentially is based on giving all of the states their lower quota first of seats. So this would be the standard quotas that we calculated in the last video, rounded down. And then based on the assigning any remaining seats based on which states have the greatest residues or fractional part of the standard quota. So this would be like 0.9 here, 0.2 here, and so forth and so on. So when we are apportioning seats using Hamilton's method, the first step is to calculate the standard quota, which we did in the last video. And then the next step is to find the lower quota, which, as you may remember from if you watched the last video, is basically just the standard quota rounded down. So in this case, that would be 4 for A, 31 for B, 38 for C, 15 for D, and 9 for E. So at this point, we have figured out all of the different states' lower quotas. So now what we need to figure out is, if we give all of the states their lower quota, how many seats do we still have left? So what we're going to do is we're going to add all of these up. So 4 plus 31 plus 38 plus 15 plus 9. That is going to give us 97 total seats. Now, at this point, what we need to do is figure out, okay, we have 3 more seats that we need to allocate to get up to our total of 100 that we have. So we need to figure out who we're going to give those remaining 3 seats to. And what we're going to base that off of is the residues. So the residue is basically just the standard quota minus the lower quota, or you could think of it as it's just the decimal part of the standard quota. So in this case, for A, that would be 0.9, B, 0.2, C, 0.6, D, 0.7, and E, also 0.6. Now, we're going to assign the remaining seats based on which states have the highest residue. So first, we're going to give one to A, because A has the highest residue, 0.9. Next highest is D with 0.7, so we're going to give D an extra seat. So that's going to put them at 16 instead of 15. And then next, we have a tie between C and E at 0.6. So in this case, we'll go ahead and pick C to give this to, so that would put us at 39. And then at this point, we've given out all of the remaining seats. So the states that we have left, E and B, are going to just stay at their lower quotas. So 9 for E, 31 for B. So now, if we add all of these up, we do get a total of 100 seats. This is how we use Hamilton's method to apportion seats. There are a few problems with Hamilton's method that we'll talk about in a later video. Mainly, they can result in what we call apportionment paradoxes. And it also doesn't take into consideration the residues as a proportion of the population of the different states. So this kind of creates a little bit of a bias toward larger states, which is also not ideal. Thank you for watching, and as always, if you have questions, I'm happy to help.